Welcome to the Journey Shake Chem. Today's warm-ups will be some good review for you. And please do them to the best of your ability and we'll review them in a moment. Number one is asking for the volume of carbon dioxide at non-standard conditions, and it is a decomposition. Therefore, we know that we must get a complete balanced equation for that decomposition, and again, we're reviewing our different types of decompositions. Well, we're beginning with 4.56 grams of the sodium carbonate, and we want to know the volume of carbon dioxide at these non-standard conditions. And therefore, I will change my grams to moles using my atomic masses, and I'm going to add up the mass of the sodium carbonate. Well, I have two sodiums, and each sodium is 23.0 AMU, and carbon is 12.0, and 3 oxygens is 3 times 16.0. And because oftentimes we make mistakes at this point, we redo the math. 46.0, 12.0, and 48.0, and when we add up, we get a total of 106.0 grams per mole. And I'm looking for moles, therefore it goes in the top. And 106.0 grams of sodium carbonate. Now I'm changing from one compound to the other, and it is a 1-to-1 ratio. And therefore, the number of moles here does not change. However, it's always good to show what the process is. And I know that 1 mole of carbon dioxide is 1 mole of sodium carbonate. And therefore, when I do the math at this point to get my moles, I come up with 0.04301 moles of the sodium carbonate. Then I will use the ideal gas law, and PV equals nRT. And I'm solving for volume. Therefore, volume equals nRT over P. Then I substitute in the values. Well, I found that there's 0.04301 moles. And my constant that I'm going to use is in atmospheres because the pressure that I'm given is in atmospheres. And that would be 0.0821 atmospheres liters per mole Kelvin. And then the temperature that I'm given is 50 degrees Celsius. And 50 degrees Celsius plus 273 will give me my Kelvin. And that will be 323 Kelvin. And then my pressure is 1.5 atmospheres. Now, when I do the math for this, I'm going to erase this part here because we're going to make a conversion as well. And the number first that I get is 0.7603 liters. And I'm going to change that to centimeters cubed. And I know that 1 decimeter cubed is equal to 1 liter. And there are 1,000 centimeters cubed in 1 decimeter cubed. And therefore, my answer here would be 760.3. And I want 2 significant digits in my final answer, and therefore it is 760 centimeters cubed of carbon dioxide. And that's how you do number 1. In number 2, we are determining the molecular weight of a gas. And I'm going to start with my ideal gas law. And it's always good to write this. And then to derive molecular weight. Well, moles is equal to grams over molecular weight. And then I rearrange my equation for molecular weight. And therefore, molecular weight is equal to GRT over PV. And in this problem, I am given 0.36 grams. And because my unit of pressure is in torr, I am going to use the constant in torr. And that would be 62.4 torr liters per mole Kelvin. And it is very important to follow through on those units. You know how much we love those units. Now, the temperature is 298 Kelvin. And that would be 25 degrees Celsius plus 273. And we divide by the pressure, and the pressure is 755 torr. And the volume is 0.5 liters, and it was already given to you in liters, therefore you don't have to change it. I know you like that part. And when I solve this, I get 17.7331. And molecular weight does not follow significant digit rules. We always go to the tens place. And therefore my answer will be 17.7 grams per mole. And when we look through this here, we can see that my unit comes out in grams per mole. My torr cancels, my liters cancel, my Kelvin cancels, and I get grams per mole. And by following through in the units, you can see if there has been a mathematical error, and you would catch that. Now, today you have the remainder of the time to work on your review sheet as you have an assessment coming up in a couple of days. I know you can do it, and you'll do it well, and I just can't wait to see you tomorrow. Bye!